All right, welcome. In this video, I'm going to be working BC Homework 12.1, writing Taylor series for a function. Okay. Let's just get started. Okay. Table of values for g of x and its derivatives at x equals -3 is given below. Let's write the Taylor series, or the third degree Taylor polynomial for g at x equals -3. All right. So we know that in general, it's going to start off, I'm going to write the skeleton at least first few times, and then I might start not doing that. But I know it's going to be g of -3 plus g prime of -3 times x minus 3 to the first power. And then second derivative, second factorial, second power of x minus -3. That should be a plus, yeah. Okay, and then the third power term will be third derivative, third factorial, third power of x plus 3. So g triple prime of -3 divided by 3 factorial, x plus 3 to the third power. Okay, and then I'm just going to go and I'm going to take these numbers from the table and plug them in here and there and there and there. Okay, so that's going to be 1 minus 2 times x plus 3. Plus g double prime divided by 2 factorial, so that's -4 divided by 2 is -2 times x plus 3 to the second power. And then 3 factorial 6, so if I took the third derivative, that's 2, and divided by 6, that would be 1/3. Okay. Use the third degree Taylor polynomial for g at x equals -3 to approximate the value of g of -2. So we're just going to take this polynomial and we're going to plug in -2 for x. So I've got 1 minus 2 times 1 minus 2 times 1 squared plus 1/3 of 1 to the third. So I've got 1 minus 2 is -1, minus another 2 would be -3. It's -2 and 2/3, which feels like -8/3. And, all right. Let f of x equal the natural log of 3 minus x. Let's write the third degree Taylor polynomial for f around x equals 2. If we don't have a table, then we're going to have to make a table. We're going to have to do it the old way. So f equals log of 3 minus x, meaning that f of 2 is equal to log of 1, which is 0. Okay. F prime, we want the third degree, so we're going to need up to the third derivative. Okay. So f prime is equaling, is it going to be -1 over 3 minus x. Okay. 1 over 3 minus x for the log, -1 for the chain rule. Okay. And I'm going to just rewrite that as 3 minus negative of 3 minus x to the negative first. That was a little sloppy, pardon me. And then f double prime equals positive 3 minus x to the -2 multiplied by -1 for the chain rule. And then f triple prime equals positive 2. I won't be fooled a third time. 3 minus x to the -3 times -1 for the chain rule. Okay. Now, I'm going to need f prime of 2 is -1. Okay, because any power of 1 is 1, so all of these things, all of these 3 minus x to the various powers, they're just going to be 1s. So I'll have f double prime of 2 equaling -1, and f triple prime of 2 equaling -2. Right, and then I'm ready to go. I'm going to have f of 2 plus f prime of 2 times x minus 2, so negative of x minus 2, plus f double prime divided by 2 factorial, x minus 2 squared. And then f triple prime is 2 over 3 factorial, x minus 2 to the third. And I probably could have simplified that a little bit, but who cares? Right. Now, h square root of x, the second degree Taylor polynomial for h about x equals 4. Okay, well, h of x equals square root of x, so h of 4 is equal to the square root of 4, which is 2. H prime is equal to 1/2 of x to the -1/2. Okay, if we look at square root x as x to the 1/2 power, And that would mean that h prime of 4 would be, all right, well, 4 to the negative half power is going to be 1 over the square root of 4 is 1/2, so a half of a half is a fourth. And then h double prime is going to be negative half of half is negative 1/4. X to the, subtract 1 from the power, that's going to negative 3/2. And so h double prime of 4 equals, all right, well, what we're going to do is we're going to take the half power first, right, when we plug in that 4. And so it'll be 2 to the negative third power. 2 to the negative third is 1 over 2 to the third, so I've got an eighth, and a negative quarter is negative 1 over 32. All right, now if we're going to go and do this, then we're going to say, all right, it's going to be 2 plus 1/4 of x minus 4 minus 1 over 32 divided by 2 factorial. 2 factorial is 2, so I might just call that minus 1 over 64 times x minus 4 to the second power. Okay, and then, what's I thinking here? Oh, no, yeah, that's the second degree polynomial. Then we need to use the polynomial to estimate the value of the square root of 3. And, well, I don't really understand where this is heading, because it's like, because it's like if you were going to use a calculator to approximate, you might as well just approximate the square root of 3 using the same calculator. But I don't know. So square root of 3 is 3 minus 4 is negative 1. Okay, so that's 2 minus a fourth. Oh, maybe I won't need a calculator. And negative 1 to the 2 is positive 1, so minus 1 over 64. Okay. Oh, I remember this problem. It was multiple choice, no calculator, where I stole it from. And it had bad-looking fractions. So like, I'll just take out the multiple choices. So, if this was free response, you'd be free to stop right there. But, maybe you are encountering the same multiple choice question I'm talking about, and you know the answer. So that's going to be 128 over 64. 1/4 is going to be 16 divided by 64, so minus 16. And minus 1. Right. So if I took away 16, I'd have 112, 111. Okay. Okay. Well, that is a number. Just for curiosity. Okay. Whoops. All right. So I've got 1.734, and then if I took the square root of 3, I get 1.732. That's pretty nice for only using a secondary polynomial, right? I find that surprising. That was like a whole 1 away from the centering point, too. That was not even all that close. So the nth derivative of f at x equals 0 is given by f's nth derivative at 0 equals negative 1 to the n times n plus 1 over n plus 2 times 2 to the n, also in the denominator for all n greater than or equal to 0. Right, the first 4 non-zero terms and the general term of the Maclaurin series for f. Okay, well, maybe I'll just kind of remind you that it would be f of 0 plus f prime of 0x plus f double prime of 0 divided by 2 factorial x squared. First 4 non-zero terms. With any luck, these won't be zeros. So, third one would be the third power term would be the fourth non-zero term. Okay, that's kind of the skeleton. Now I'm going to say, all right, f of 0 is when I plug in 0 for n. It's the zeroth derivative. So I'm going to make a little table over here. That's 1 over 2 times 2 to the 0. Okay, so this is going to be a half. F prime of 0 is where n equals 1. So that would be negative 1 times 2 over 3 times 2 is going to be 2 over 6. Yeah, so I got negative 1/3. Okay, and then I'm going to need f double prime and f triple prime. All right. Positive 1. 2 plus 1 is 3. Over, when n equals 2, I've got 4 times 4 is 16. Okay. Now, go back over here, triple prime, I'm going to have a negative. Okay. When n is 3, I'll have 4 in the numerator. And so n is 3, so that's 5 times 8 is 40. Okay, so we'll be able to simplify that when we need to. Okay, we're going to write the first 4 terms. Okay, yeah, first 4 terms, and then I'll work on the general term in a second. So, because we'll just probably be using that part. So, f of 0 plus negative 1/3 of x plus f double prime divided by 2 factorial. So if I divided by another 2, I'd have 3 over 32 x to the 2. And then plus f triple prime over 3 factorial. So I'm going to have negative 1/10, but then I'm dividing by 3 factorial. That would be negative 1 over 60 x to the 3rd. That's the first 4 non-zero terms. Now the general term, okay, so the different color here. Been away for too long. Let's put away all my pens. So I've got. So I know that the general term is the nth derivative of f, and since we're talking about a Maclaurin polynomial, it's going to be evaluated at 0. Nth derivative, nth factorial, nth power of x. Okay. And fortunately, we've got our formula for that right here. So I'm just going to kind of combine this with all of that, and that'll be my general term. Okay, so it's f's nth derivative at 0. In the denominator, I've got an n plus 2, a 2 to the n. And this n factorial. Okay, and that will be my general term. Okay, so suppose g has derivatives of all orders with g of 1. This is basically a table question, right? They just didn't put it in a table. Write the third degree Taylor polynomial for g around x equals negative 1. Okay. Well, we know that. I'm going to write down the skeleton. Okay, and now we're just going to fill in these numbers that we were already given. G triple prime would go here, G double prime there, you know, all this stuff. Okay. So G of negative 1 is 4, plus negative 2, plus G double prime divided by 2 would be 3. And G triple prime 12 divided by 3 factorial, 3 factorial 6, so that'll be 2. Wait a second, I don't need a calculator for this next one. I thought we were going to need a calculator for this, but that's just not going to be necessary at all. G of negative 0.9, I'm just going to take x and I'm going to plug in 0.9 for it. So 4 minus 2 times negative 0.9 plus 1 is 0.1. Plus 3 times, if I plug in negative 0.9, I'll get that positive 0.1, I'll square it, I'll get 0.01. And 2 times same thing, 0.1 to the 3 is 0.001. And that means, oh man, I wish this was a plus. That would be ideal, because then it would be 4.232. Okay. Okay. 4 minus 0.2 would be 3.8. And now I'll have 3.83 and 3.832. That's probably the best arithmetic I've seen all year. All right, let f be a function with f triple prime of x equals 1 over the cubed root of 1 minus 4x. What is the coefficient of x to the fourth in the Maclaurin series for f? This is a good problem. Okay, this is the type of problem that's going to kind of keep coming up. But it's also on the quiz, so it'd be a good time for us to do it. So let's see if I can switch up the color, right? We know that the coefficient of x to the fourth, or the Maclaurin series, it's, you know, f of 0 plus f prime of 0 times x, f double prime divided by 2 factorial x squared, you know. But then when we get to x to the fourth, we want f's fourth derivative evaluated at 0, divided by 4 factorial x to the 4. You know, there's going to be a bunch of terms after it. There's going to be a bunch of terms before it. So the coefficient is this thing that I'm going to be boxing off here. It's f's fourth derivative divided by 4 factorial. So what we're going to need to do is we're going to need to take the derivative of f triple prime. That's why they gave you f triple prime, is so that you would take the derivative of it. Okay, so I'm going to say f triple prime equals 1 minus 4x to the negative 1/3 power, meaning f's fourth derivative is going to be negative 1/3 times 1 minus 4x to the, okay, if I subtract 1, I'll have negative 4/3. Okay. And then we will multiply by negative 4 for the chain rule. Okay, when I plug in x equals 0, because that's what I'm going to need over here, okay, I'm going to have negative 1/3 multiplied by some power of 1, which is always going to be 1, and multiplied by negative 4, so that's equal to 4/3. Okay, so that coefficient is going to be 4/3 divided by 4 factorial. If you wanted to say that that was, I don't know, 1 over 18, maybe, I don't know, you can, but I'm not going to. I'm just going to stop there. The nth derivative of f at x equals 1 is given by f's nth derivative at 1 equals n3 to the n over n plus 2. Coefficient of x minus 1 to the 2 in the Taylor series for f centered at x equals 1. Okay. So we know that the Taylor series, much like what I was saying before, it's going to be kind of, you know, having a f value and f prime value, but we're interested in the second derivative, second power, second factorial term. So that would be f double prime of 1 divided by 2 factorial times x minus 1 to the 2 power. Okay, again, this is the coefficient I'm interested in. I need to just figure out what f double prime of 1 is. Okay, that's going to be where n is equal to 2. Okay. So 2 times 9 divided by 2 plus 2 is 4. So I think that's going to be 9/2. So as a result, my coefficient is going to be f double prime is 9/2 divided by 2 factorial. Okay, which does end up being that 9/4 again, so that's, you know, probably not. I would be more careful on the quiz to make sure that you weren't, you know, right for the wrong reason. Okay. When g of x is sine of x to the fourth, then h of x is equal to the integral from 0 to x of g of t dt. Oh, okay, so this one, there was a problem very similar to this on the notes book, right, where we start with the Maclaurin polynomial for sine of x. Then we go to sine of x to the fourth, then we're going to anti-differentiate. Okay. So we'll start with sine x. First 3 non-zero and the general term. Okay. Sine of x is going to equal x minus x to the 3 on 3 factorial. We know this one. And, you know, since I'm going to be like doing a couple of steps, I think I'm going to write the general term just in line with the other one, so I can manipulate on it the same way I'm manipulating on the rest of the terms. Let's see, just off my shot a little bit. 2n plus 1 factorial and alt. Okay, meaning sine of x to the fourth So I'm just going to replace every x with an x to the fourth. So that's an x to the fourth minus x to the fourth to the third power divided by 3 factorial. X to the fourth to the fifth divided by 5 factorial minus x to the fourth to the 7 over 7 factorial. Okay, what did I do? I just replaced x with x to the fourth. Now, because I know I'm going to, and I didn't change the denominator. And I also know that because I'm going to eventually be anti-differentiating, I'm going to want to simplify this. Okay, so this is going to be x to the 4 minus x to the 12 over 3 factorial plus x to the 20 over 5 factorial minus x to the 28 over 7 factorial, so on, all the way until, oh, I haven't really, I'm just simplifying here, so maybe I'll simplify, whoops, forgot that, and multiply this by 4, right? It was what I was doing, multiplying exponents, so 8n plus 4. Okay, that's my general term. And now I can find g, that's, well, I guess that's g of x. Okay. You know, supposing there's a plus dot 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 on the outside, and that's an equality. And that means that h, I'm going to anti-differentiate term by term. So antiderivative here, 1/5 x to the 5th. Add 1 to the power. Divide by the new power. Okay. Add 1 to the power by the new power. Okay. And now what I've been doing this whole time has been adding 1 to the power and dividing by the new power. So that's exactly what I'm going to do to the general term. So I have 8n plus 5 divided by 2n plus 1 factorial. I really think that this is an example of one where if you had not followed the process through the general term, it would have been really hard to look at this pattern and try to come up with the general term just on your own. Okay, so I really do recommend you know, copying down the general term at the beginning and tracking your changes to that so you can get a, you know, a general term at the end without too much difficulty. Okay, but this is definitely the type of problem you need to be aware of. All right. The Maclaurin series for this function f is given by 2 plus 3x plus x squared plus 1/3 x to the third, and so on. Is there a pattern there? Oh, okay. This one is, okay, yeah, this one I put on there and I meant for it to be the last one. I meant to label it as like a challenging item, but you know, here we are. Okay, so what I really need is, if I want the coefficient of x squared in the Maclaurin series for g, I know that it's going to look like, you know, g double prime of 0 divided by 2 factorial, right? And so I think what I'm going to do, rather than putting the polynomial inside the other polynomial, which is not going to be the thing to do in this class ever, it's going to be find g double prime using the chain rule, and I guess the product rule. But we have a bunch of information about f that's hidden in here, okay? Okay, so, well, g double prime of x, I'm going to just find g prime of x is equal to e to the f of x multiplied by f prime of x for the chain rule. Okay. And then I'm going to have to take the derivative of this with the product rule, and, well, that'll be all right. All right, so I'm going to take the derivative of this one and leave that the same, because I know how that's going to go. Okay, I've left this one the same, and it's going to incur an extra power of f prime of x. And then I'm going to leave e to the f the same and take the derivative of the second piece, so that'll be e to the f of x multiplied by f double prime of x. Okay. Now I think I just need to extract ingredients from the Taylor polynomial for f. Okay. So I'm going to take this to mean that f of 0 equals 2. Okay. So I'm going to say, all right, g double prime of 0, I forgot to, e to the f of 0 multiplied by f prime of 0 squared plus e to the f of 0 multiplied by f double prime of 0. Okay. Right, now I'm ready to scratch these out and replace them with 2's. Okay. F prime is going to be easier to come by as well. That's just going to be 3. F prime of 0 equals 3. Okay, so that'll be 3 to the 2 power. Okay. And then f double prime, that's going to take a little more work though. Okay, because 1x squared, make sure you can see, is equal to f double prime of 0 divided by 2 factorial x squared. So that means that 1 is f double prime divided by 2 factorial. This is the type of thing that we're going to do a lot in the next lesson. We haven't really done that much yet. But you could say, okay, cancel off the x's. F double prime is going to be equal to 2. Okay, so now I've got g double prime of 0 equals e to the 2 times 3 to the 2 plus e to the 2 times just regular 2. So it looks like I'm going to have 11 e to the 2's. That was nowhere close to what you could see. So the coefficient of x squared is going to be 11 e to the 2 over 2 factorial. Okay. That one was pretty challenging, but I don't know. Not the worst. So number 10. F has derivatives of all orders with table given up to 4th derivative. Let capital F be the integral of lowercase f, and let capital G be the derivative of lowercase f. All right. Yeah, we're just going to write, we're going to write 3rd degree polynomials for f and big F and big G. All right, we can do that. So 3rd degree polynomial for f at x equals 0. That's a Maclaurin polynomial. So it's 3 minus 4x. Remember that at x equals 0, I can even write this. F of 0 plus f prime of 0x plus f double prime divided by 2 factorial x to the 2 and f triple prime of 0 divided by 3 factorial x to the 3. And I just fill in the numbers. 3 minus 4x plus, what was f double prime? That's 2 over 2 factorial is 1x squared. Triple prime is 1, so that's 1/6 of x to the 3, and that's my 3rd degree polynomial. Okay, capital F is an antiderivative for lowercase f. So if I take an antiderivative here, I'm going to incur a plus c, and a 3x, and a negative 2x squared, and a 1/3 x to the 3rd. And I'm going to see that when I plug in x equals 0 into capital F, I need to get 0 back, so 0, 0, 0. I need c to equal 0. So I'm just going to do that. Okay, and then the 3rd degree polynomial for capital G, I'm just going to take the derivative of f, because that's what g is to f, is its derivative. Okay, so I'm going to say the derivative of 3 is 0, be negative 4 plus 2x plus 3/6 of x to the 2. I'm just taking the derivative here. But it's like, it wants the 3rd degree Taylor polynomial. What do I do? Okay, well, the 3rd derivative of g, if I just take derivative 3 times, that's going to be the 4th derivative of f. So that would be 48. Third derivative of g is 4th derivative of f. Divide by 3 factorial x to the 3rd. Okay, if you wanted to call that 8x to the 3rd, pardon me, that's where I was working, then you could be my guess. All right, I think that's all we got for this video. Thanks for watching.